In this question, we have a string. Attached to the string is a ball, and that ball is flying in a horizontal circle, like so. And we're asked to draw labels representing the forces of the ball. So we have the weight, always, and we have a force of tension, like this. Now, it's important that we spell out the fact that the tension is larger than the force of gravity. I mean, we might even want to put it here and say force of tension is greater than force of gravity. Because if we look at our free body diagram a little more closely, the force of tension is broken into the tension in the x direction and the tension in the z direction. And the x direction is what's causing the centripetal force. So if we draw ultimately the components, we have FTZ being equal and opposite to the weight, and that leaves just the component in the x direction. So now we're asked to state and explain whether the ball is in equilibrium. Well, so we start out with a definition. Equilibrium means that F net equals MA equals 0. The forces are balanced. And A equals 0. Although the forces are balanced vertically, they are not balanced horizontally. Resulting in centripetal acceleration. If there is acceleration, or since there is acceleration, non-zero acceleration, the ball is not in equilibrium. So again, we start with our definition. And we have our observation. And our conclusion, related back to the definition. Next, we are asked to determine the speed of rotation of the ball. Well, we know that this Newton's second law helps explain an awful lot of things, and so we have F net equals the sum of the forces, and net force is ma, and that acceleration is centripetal. And the sum of the forces left over, the unbalanced forces, or the forces causing the acceleration, is ftx. And centripetal acceleration is mv squared over r. And ftx, well, let's come up with an expression for ftx. We know this angle is 30 degrees. Adjacent side, hypotenuse, or an ft. This is ftz, and this is ftx. And that's the opposite side. So we'll do our trig. Sine of 30 is ftx over ft, and therefore ftx is ft sine 30. Problem is we don't know what ft is. So let's go further. Cosine 30 equals ftz all over ft. So ftz equals ft cosine 30. And this is where we get a nice substitution because we have balanced forces vertically. The ftz and the fg are equal and opposite. They're balanced. So we know ft equals fg. So ft2 equals mg cosine 30. And we know the mass is 0.25, 10, and cosine 30. I made a mistake here. I knew what it was. It was going too quickly. ftz is equal to fg. So we have fg equals ft cosine theta. And that is mg. And so if we're solving for ft, the overall tension, we need to know it's fg over cosine 30, which is mg over cosine 30, the mass being 0.25 times 10 divided by cosine 30. And that gives us an ft equal to 2.867 newtons. Now, armed with that knowledge, we can come back to our ftx, and we know it's 2.867 times the sine of 30, which is 0.5 or 1/2. And so we end up there with 1.3. Oh, we don't put it in there, excuse me. mv squared over r, and ftx is ft cosine 30, or ft sine 30. So that means that for velocity squared, we are left with the velocity squared being ft sine 30 times r all over m, and therefore v is the square root of 2.867 times the sine of 30, which is 0.5, times r, which is 0.33, and the mass, which is 0.25, and that gives us a velocity of 1.3803 meters per second, and to two significant digits, the velocity is 1.4 meters per second. And that's the speed of the ball. Some of you may recognize this as being exactly the same situation as an airplane suspended from a string traveling in a circle.